Alright, so I guess with this last bit, we'll talk specifically about the final exam. If you have questions about certain topics that we covered, like you're still a little bit shaky on regression or shaky on ANOVA or shaky on one of the topics, I'll be happy to answer those questions as well. Okay, so I'm going to ask a bunch of questions, kind of like these theoretical questions on like the ideas behind hypothesis testing and inference and things like that. Okay, so there will be a bunch of kind of theoretical questions. Or theoretical / conceptual questions. We can go into, I guess, a little bit more detail on that. And then I will also, like I said, methods, descriptions of scenarios. Which test is appropriate. Okay, and then the bulk of the test will be, can you do this test correctly? Can you do the test, right? So, in no particular order, you'll definitely see t-test, and you'll see paired t-test. So most of these, I will say, do this test, okay? Wilcoxon and Whitney. There will be ANOVA. I know, it's a lot, okay? There will be correlation, regression. The chi-squared, test for independence. Chi-squared goodness of fit test. And then a few, just a handful of kind of, big picture, what is statistics all about type of questions. Okay, big picture questions. And then maybe just a few definitions.
What kind of definitions?
What kind of definitions? Yeah, that's a good question.
And is it going to be multiple choice?
Yeah, it's going to be, the entire thing's going to be multiple choice.
What about confidence intervals?
Oh yeah, there will be a chi-squared goodness of fit test and a confidence interval question. Confidence interval for tilde. Oh yeah, confidence intervals related to the t-test, and they'll also make an appearing in the conceptual question. We'll get a little bit more. I'll do some more detail there. Big picture type questions, definitions.
What about those trees, probability trees?
Probability trees.
Yeah, that'd be cool.
Huh?
That's great. Probability trees would go.
Yeah, some IQR.
I don't know, you can all mistakes on the probability. They're easy to make mistakes on this.
Easy to make
Like a
mistakes
bunch
on
of
probability trees?
factorials.
Yeah, I think there will be, trying to think. I'm still tweaking it. Yeah, let's throw in a probability tree.
Sorry, Steve, sorry.
Okay. Alright, and then so for the probability tree, no, probability of A given B versus probability of B given A. Okay. I'm not trying to be evil. It's just We covered a lot in this class, so yes, Erica. Anything else from before the midterm?
Yeah, how about just this stuff, but you can't put anything else on it. And if you do, then we can be like,
If
yeah,
you could fit
check
like
that
anything
out.
in those
Right.
categories.
Okay, no, I think, well, this is enough here for you guys, alright? So, I mean, stuff from before the midterm might make an appearance in this definitions, big picture question section, alright? But that probably won't be more than 15% or 10 or 15% of the stuff, so.
So it'll probably be like a bunch of like shorter questions or problems, not like, you know, one problem and like 8 or 9 questions that just build on that one problem.
Yeah, so these, okay, so for all of the different tests, okay, it will probably come down to like, okay, so for each test, you should know what the appropriate hypotheses are, okay? So, I mean, I'm not gonna ask the same questions for every single one of these things, okay? But know what the okay. So the appropriate hypothesis, right? So for like a t-test, so t-test independent groups, the hypothesis is what? mu1 equals mu2 or mu1 minus mu2 equals 0 versus mu1 minus mu2, you know, whatever, doesn't equal 0 or something like that. Okay, but and some of these are, you know, subtle differences. For paired groups, what's the hypothesis for paired groups? The mean difference is 0, right? So I'm not trying to be evil, but there is a difference, right? So fair warning. Okay, and you got a bunch of other hypotheses to know. Okay, so for each test, you should know the hypotheses. Okay, and then there will be some numbers, and so you should be able to get the appropriate test statistic, value of the test statistic. Or perhaps I'll ask you for the value of the standard error, or some other quantity that goes into the calculation of it. So this only applies to some, you know, when applicable. Like for ANOVA, I might say, what's sum of squares between or something, right? It's just one of those values. Okay, and then you should be able to find the p-value. Okay, so calculate the value of the p. Now, because, like, if you messed up the test statistic, okay, then your p-value is going to get messed up. All right, so I'll try to break the dependency there, just so like you mess one thing up, it's not going to like mess up like the next however many questions. So probably what I'll ask, what is the test statistic? And then I'll say, okay, let's pretend your test statistic was this. What would be the corresponding p-value or something, right? And then you'd have to look in the table.
Do we need our tables?
Yes. So bring your tables. I'll make a few extra copies if your tables got destroyed.
What
or something.
about like the F table?
You don't need the F table, okay? Because the F table is too many pages. Like I might say, what numerator and denominator degrees of freedom would you use to look up your F statistic, okay? But then I won't say go to the F table and give me the p-value, okay? I figure if you can figure it out for the chi-squared, like if you know how to use the chi-square table and the t-table and all the other tables, I'm pretty sure you'll know how to use the F table, right? It's all exactly the same, so I mean pretty much the idea. So I'll say value of the p-value given a particular test statistic, okay? So this is really like, can you use the table? And I'm pretty sure most of you can. So, yes?
And then are you gonna, sorry, I hate to
Yeah,
do
yeah.
this on this. Are you gonna like tell us whether it is directional or non-directional on those types of tests, or do we just kind of need to know by the way the test, or the way the question is written?
Yeah, you will need to know by the way the question is written, okay? So, yeah, I'll try not, like, I don't want to, it's tough writing a good test, right? Because the directional or non-directional will make an appearance in picking the appropriate hypotheses, and it will also make an appearance with the p-value. So I'll try not to make it like so intertwined where it's like something, but okay, so just know how to do each test, I guess. Hey, you're allowed a full sheet of notes front and back. What else do we need to know for each type of test? Let me just check. Let me do my phone.
Is there gonna be any, like, how would you do this problem in R kind of question?
No, I won't put any R
Yay.
R stuff. I know, you know, that would be one thing I could change about this class, but I know you guys would not make that request, but I would want to add more R stuff here. Let's see.
Do we get to bring in a page of notes?
Yes.
Front?
Front and back, okay? Letter size, paper, okay? Newspaper, tabloid sheet, yeah.
Sheet of picture paper.
Okay, and then, you know what would it mean to commit a type 1 or type 2 error, okay? I think that's so if you can do all of the different tests and kind of be able to answer these types of questions, okay. So there might these aren't going to be the exact questions, but some variant of these things. But basically, if you can do the test properly, figure out the p-value, value of the p-value, and then of course make a conclusion, right? And the conclusions, because it's multiple choice, won't just be reject the null or don't reject the null. It'll probably be like, reject the null, this means we have evidence of something, okay? And then there will probably be another one that says reject the null, this means we have evidence of something else, okay? And the answer choices, one will be correct and others will be wrong, but might sound kind kind of correct, okay? Cause I think sometimes when we make our conclusion, like we can go through the process and we can reject the null hypothesis, and that's fine and all. But then for whatever reason, I think I've noticed students get the interpretation of rejecting the null wrong. Okay. Appropriate conclusion with the correct interpretation. It's not incredibly hard, just it's very thorough. I would say the test is. Okay, so let's talk a little bit about these theoretical or conceptual type questions. And then again, if you have any questions on particular concepts or topics, I'll be happy to field them. All right, so at the end of what is a p-value? Can you tell me what a p-value is? What does it mean to get a p-value of 0.8? What does it mean to get a p-value of 0.02?
The probability of observing our data or something more extreme.
If
Oh, yeah.
if the null hypothesis were true, right?
Yeah.
So if H0 were true, we have a 0.02 probability of observing our data. Or something more extreme. Yeah, exactly. Okay. So if your p-value is less than alpha, what does that mean? Okay. It means, well, there's a bunch of things. It means we reject the null. Okay. We accept the alternative. Okay, we have enough evidence to reject the null or accept the alternative, okay? To support or to believe or accept. Alright. And be careful with the wording here, okay? Because we never say we accept the null. Okay. But that might look like a tempting answer choice, right? On the other hand, if our p-value is greater than alpha, does that mean we reject the alternative?
We also reject the null hypothesis.
Okay, we don't reject the null hypothesis.
We say we don't have enough evidence to support.
Yeah, so we don't reject null. And we say, yeah, we don't say we reject the alternative, and we don't say we accept the null either, okay? Don't say or any variant of that, okay? Okay, you know, relationship between a t-test and a confidence interval. You should know that. We saw some of these on like that quiz. You know, how might your conclusions change if you used if you used the same data but a different significance level, okay? The relationship between alpha, beta, power, type 1 and type 2 error. So in general, increasing alpha, how does that affect beta?
Can it increase the chance to make a type 1 error?
So increasing alpha increases the chance of a type 1 error. How does it affect the others?
Lowers beta.
It lowers our beta, which lowers our chance of type 2 error and increases our power. So if we want higher power, we can increase our alpha, but we're also increasing risk of type 1 error. And if we want to lower alpha, we're probably also lowering power. So, things like that. You know, when is it preferable to pick large alpha or small alpha? When do we want a large alpha?
We would rather be wrong, like the fire alarm.
Yeah, so we pick a large alpha when the type 2 error is worse than the type 1. And we pick a small alpha when the type 1 is worse than the type 2. If we had to choose being wrong.
I'm sorry. We pick a large alpha
When the type 2 error is worse
that's right.
than the type 1 error.
That's for small, right?
Big alpha, so large alpha, type 2 error is worse than type 1 error. And over here, for type 1 is worse than type 2. What else do you guys need to know for this conceptual section? Alright, maybe the difference between a directional and a non-directional test, and how that might, your choice might affect your p-value, okay? That's all I can really think of for this conceptual section. That's it.
Yes.
Do you know anything about like calculating the appropriate sample size or relationships?
I'm not gonna ask that for appropriate sample size, because we didn't really get into that. It was briefly mentioned for confidence intervals if you want a certain margin of error. That was in your homework. It comes up a lot of times in ANOVA and power calculations, but we didn't get into power calculations, so I won't put that on there. Okay. Any other questions? Now's your time to ask. Everyone's good on all the different tests and what to do?
Just don't remember which ones we're bad at.
You just don't remember which ones you're bad at, okay.
Or worse at.
Okay. So go over your quizzes and your homeworks. Yeah, just make sure you can do all of those different tests and the things. Okay. If there aren't any questions, I'll let you guys go early. And if you do have questions, I'll be happy to answer them. So.
Woo!
All right. Okay. Well, thank you for.